Welcome. In this video I'm going to show you how you can perform a g-test, or sometimes known as a likelihood ratio test of goodness of fit. I think this is also sometimes referred to as a Wilks test of goodness of fit. I'm going to do this by example. This file will be on my website available, peterstatistics.com, if you want to download it. The data is over here, and the first step is we need to determine how many categories I have, in this case 5, and these are those 5 categories. Now I need the frequencies for that, so I'll be using equals count if, and then the entire column A. My Excel is set that I use a semicolon to separate parameters. Perhaps yours is using a comma, so be careful there. And my criteria is, of course, the value that is over here, that was married. I can then just copy paste this down or use the autofill handle, and just to double check, yes, this works just fine. The total is, of course, the sum. Alt equals is a shortcut for the sum of those. Then we can do the expected count. Now I'm just going to expect that each category was equally likely to be chosen. So in that case I can simply say, well, it's going to be the total, which is over here. F4, so that when I copy paste it, the dollar signs are placed around it, so that if I copy paste it, it won't change. Divided by the number of categories, which is over here, and again an F4 just to put quickly the dollar signs around it. So I'm expecting 388.2 in each of the categories. Again, just copy paste down. Now we need to calculate the logarithm of those observed frequencies divided by the expected frequencies, and then multiply that with the frequency. Now in case this might have been 0, we should just leave this at 0. So what I'm going to do is I'm going to start with an if, and then if the value here equals 0, then just return a 0. Otherwise follow the formula, so then it's going to be this f10 multiplied by the natural logarithm of, and then in this case it's going to be this observed frequency divided by the corresponding expected frequency. Close the parentheses, both of them, and there is the result. I can copy paste this simply down, and this should work. Just to double check, it seems to be working as intended. Alright, we need to sum the results, so I can simply say equals sum, and then select these, and that's the total. So that's this big weird looking E. It simply means just to sum all of them. Now the chi-square value for this, or the G value if you will, is now twice that entire sum. So I can simply say, well, that's going to be 2 times and then this one. Now because this will follow a chi-square distribution, we also need the degrees of freedom, and for a goodness of fit test it's going to be the number of categories minus 1. So that's going to be, for me, my number of categories, which I had over here, minus 1. And that gives me 4. Finally, I can then use the chi-square distribution function in Excel. I actually want the right tail because we want or more extreme. So what we can do is chi-square dist and then RT for right tail. If you're using the older version, dist, you could do just 1 minus the left tail. I'm going to use this one for now. So my x is my chi-square value, and my degrees of freedom is over here, which is 4, and that should be all I need to do. So the E minus 245 basically means, from the top of my head, that you have to divide this 7.187. You have to divide that by 10 to the power of 245, so that's going to be extremely small, like 0.0000, about 244 zeros, and then 7817. So this is far below the 0.05, so we would reject the null hypothesis. The null hypothesis would be basically saying that these would roughly match these, and they are significantly different. So not each category was chosen equally likely. I also actually made a user-defined function for this, which I'm not going to run here because it actually takes quite some time. I could actually use this one. This uses the frequencies rather than the raw data. So here, if I copy paste this in here, it will simply give me the same result as you can see over here. If you add parameter 1, you actually get the g value itself. So if I change this to semicolon 1, then I should get the g value. And the last thing is, if you use a 2, it gives you the degrees of freedom, and these three are the ones you usually need on to reporting the results of this. If you're interested on how to report this, check my website. This was intended mainly to show you how it can be calculated. Alright, hope this was helpful, and thank you for watching.